All right, so today we're going to look at our first lesson. This is 1-1, Unit 1, Lesson 1. That's what the 1-1 stands for. And this is about number systems. So there are two main type of number systems that you'll run into in your math career, and that is the real numbers and the imaginary numbers. So the imaginary numbers are not something that you're going to be dealing with a lot in Algebra 1. Your imaginary numbers are more of an Algebra 2 topic. It's an Algebra 2 topic. We're not really going to deal with imaginary numbers in Algebra 1. We're going to focus on the real numbers. And your real numbers are basically any number that you're going to run into in Algebra 1. So you'll see that there's a document or an image in here that says the real number system, and it kind of goes through all the number systems. So the way this works, this is kind of like an umbrella hierarchy. So you'll see this real number systems is everything inside of this box. So every one of these number systems we see in here is considered a real number. So the real numbers are, the rational numbers are, the integers are real numbers, the whole numbers are real numbers, the natural numbers are real numbers, and so are the irrational ones because they're all within that big yellow box or that big box. So now, within the real numbers, we have two main types of numbers that you'll run into. And those are your irrational numbers. Actually, that's not very easy to see. Your irrational numbers and your rational numbers. Your rational numbers, and we're going to make note of this, your rational numbers are any number that can be written as a fraction. So I'm just trying to figure out how to write this or where to write this. I'm going to do a little arrow. So rational numbers are every number or any number that can be written as a fraction. Rational numbers are numbers that can be written as a fraction. So we're going to add some more examples in here because we don't have any fraction examples. We have all these decimals. So 2/3 is a rational number. You can have mixed numbers, 1 1/3, -1 1/3. Any number that can be written as a fraction is a rational number. So then on the flip side of that, if we're dealing with an irrational number, irrationals are numbers that cannot be written as fractions. Cannot be written as fractions. Irrational numbers are known as never-ending and non-repeating decimals. Our rational numbers or repeating decimals fall under the rational ones because 2/3, 1/3, those can be written as fractions. So let's make a note of that in here. Rational numbers include, I didn't want that to be that large. Let's go this one. They include repeating decimals. So our most common irrational numbers that we'll run into are these square roots that aren't perfect. So the square root of 2, the square root of 3, pi is that most famous one, and the square root of 11. Not to confuse those with numbers like the square root of 25. The square root of 25 simplifies to just be plain old 5, which makes it rational. The square root of 2 and the square root of 3 and the square root of 11, those are irrational because they're not perfect squares. The square root of 25 is what's called a perfect square because it comes out evenly. 5 times 5 is 25. Okay, so then moving on. So a number cannot be both rational and irrational at the same time. It's one or the other. It either can be written as a fraction or it cannot. But both rational and irrational numbers are both real numbers. So then if we further down here, we have our rational numbers, and inside the rational numbers, we have our famous integers. Those integers are just sorry, I got distracted for a second. Integers are just positive and negative whole numbers. No decimals or no fractions in the integers. And then in the integers, so every number that is an integer, every positive or negative whole number is also considered a rational number. Because remember, I can take any whole number like 3 and turn that into a fraction by putting it over 1. And every rational number is also a real number. So within the integers, we have this another set called the whole numbers. And these are just your whole numbers. No decimals, no fractions, but this one has no negatives. These ones are just positives. And last but not least, you have the natural numbers, which has everything in it that the whole numbers does, except for 0. So the natural numbers do not include 0. Do not include 0. Okay. So let's take a look at our first example. Our first example is example 1, obviously, and it tells us to list the number sets that include 0, or that should say include, not included. List the number sets that include 0. So if I go back up to my chart here, we just finished talking about that which set does not include 0, the natural ones. So the natural ones don't include 0, but I can see right there that the whole numbers do. So whole numbers. The integers, because those are positive and negative whole numbers. Is 0 a rational number? Can 0 be written as a fraction? Yes, I could very easily take 0 just like any other whole number and put it over 1. So they are rational. So if 0 is rational, can it also be irrational? Do those bubbles overlap? Are the irrational numbers inside the rational? And the answer to that is no. It can't be both rational and irrational. So 0 is rational, but not irrational. And last but not least, we're missing the real numbers. Because remember, any number you deal with in Algebra 1 is going to be considered a real number. Imaginary numbers we're going to save for Algebra 2. Okay, so moving on to example 2. What number set, so those are the things we just went over, natural numbers, whole numbers, integers, rational numbers, which one of those number sets would be best to represent the amount of money in a bank account? So the best way to kind of work through these questions is just to go through each of the sets and think about which one is most accurate. So if I'm talking about how much money someone has in their bank accounts, the smallest circle or the most exclusive one is the natural numbers, and it does not include 0. Is that true? Can someone not have $0 in their bank account? $0 is definitely a possibility for a bank account, so it would not be the natural numbers. So then we go to the whole numbers. While the whole numbers have 0, they don't have any negatives in them. And trust me, because I know by not getting paid all summer, when the end of summer comes, the bank account is very, very low, and sometimes it could go into the negatives if you overdraw your account. So whole numbers are no good because it doesn't have negatives. The integers have negatives, but the integers don't have decimals. And it is okay to have a decimal amount of money in your bank account, right? Those are your pennies, your cents. So it can't be integers. So that leads us to rational numbers. Can it be rational or irrational? Oops, excuse me, sorry there. Rational or irrational? Well, can you have a never-ending, non-repeating decimal as your bank account? Do you have $999 and, points 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, decimal points? No, your decimal points stop at the hundredths place. So it can't be irrational numbers. And it can't be the real numbers because irrational are real. So that means your best case here, your best situation would be those rational numbers. So I'm going to say rational because they include, and all those things we talked about, they include decimals, 0, negatives, and are ending decimals. Yeah, that's not a good answer. Let me erase that. I disagree with that. Because they include decimals, zeros, negatives, and that's really it. Let's just call it there. They include decimals, zeros, and negatives. And a bank account. There we go. There's the other sentence I was thinking of. And a bank account might have all of those. Not sold on my English on that question, but hey, bear with me, all right? All right, so rational because they include the decimals, zeros, and negatives, and a bank account might have all of those. You could have $0 in your bank account, you could overdraw your account, or you could have positive. All right, last little example here. Example number 3. If you multiply an irrational number by an irrational number, will the resulting product be rational or irrational? And is that always the case? So let's review. An irrational number is a never-ending, non-repeating decimal. So if I take a never-ending, non-repeating decimal and I multiply it by another never-ending, non-repeating decimal, that's going to end up with a bigger never-ending, non-repeating decimal in most situations. Let's see if I have a calculator on here we can use. There it is. Obviously, this isn't our our graphing calculator, but we'll go from there. So our famous example of an irrational number is pi. So if I go to my calculator and I type in, and they're not even going to give me pi in here, are they? Of course. Oh, there it is. Okay. So if I do pi times pi, look what I ended up with. Another really long, never-ending, non-repeating decimal. So that doesn't work. What if I take clear? What if I take pi times a different irrational number, which could be the square root of, oh, I don't understand how to work this calculator. La, da, da, da. So let's do the square root of 5. So square root of 5 times pi times 5 square root. There we go. I don't even know if that worked or did anything. But either way, you can see that I'm still ending up with a never-ending non-repeating decimal. Okay, so we tried so far, we tried pi times pi, and that gave us irrational. We tried pi times the square root of 5, which gave us irrational. And so now what if I try the square root of 5 times the square root of 5? Let's see if I can figure this out on the calculator. So the square root of 5, it keeps not doing what I want it to do. Clear. Square root of 5. I think I have to put the 5 in first and then square root it. Yes. Okay. So the square root of 5 times, put the 5 in first, square root it. Enter. Boom. Look at that. The square root of 5 times the square root of 5 gave me 5 back, which might seem weird at first. But if you think about it, the square root of 5 times the square root of 5 is just the square root of 5 times 5 is 25. If you go to your calculator and put 25 in, or the square root of 25, that would get you back to 5, which 5 is a rational number. So when you multiply an irrational number times an irrational number, the product will not always be irrational or rational. It's going to depend on the numbers that you use. So let's go to that. An irrational times an irrational does not always result in a rational or irrational answer. It depends on the situation. And you can see that above in our examples here. We got pi times pi was irrational, pi times the square root of 5 was irrational, but then the square root of 5 times the square root of 5 was rational. And to prove that again, if we went and did a similar example, like the square root of 10 times the square root of 10, that would also end up giving me a rational number. Okay, so there are our number systems for 1-1. Congrats, you made it through your first lesson in notes.